And welcome again, Cougar Academy 2A. This time we are going to be factoring polynomials. Here's where it starts to get a little more challenging. So factor each completely. What we're going to be doing is either removing greatest common factors. So we're going to be checking for GCFs or greatest common factors, and also breaking down trinomials. Okay. So this first one here, it might be difficult to see, but these two things, so we're going backwards from multiplying, they each share an x, so to speak. Okay? So we're going to undistribute that x. When we do that, it's like taking an x away from this one and taking one from this one. So we're taking that away. What that leaves us with is an x minus 1. And that is our factored answer. And what you're like, what's going on? With removing greatest common factors, it's always easy to check. Let's just see, if we were to redistribute this, x times x is x squared, x times negative 1 is negative x. It checks out. You can always do the Dvorsky double check. That's my name, to help you there. So sharing x is undistribute. Let's think of something else. If we say had 5x squared minus 25x, okay, what they each share is a 5 and an x. So if we think about undistributing that, if we divide this by 5x, which is out front here, and 5x, that leaves us with x minus 5, and that would be your answer for that particular problem. Okay, greatest common factors. Moving on to the next type, these types here, so we're going to be factoring a trinomial. If we think of each of these first and last terms, and we start to write the factors, I like to call these the factor tree method. Christmas coming up, I believe. So factor trees, we're just going to list the factors of r squared, which are r and r. And the key is to find the factors of negative 72 that add to negative 1. So factors of negative 72 that add to negative 1. Factors of negative 72 are negative 9 and positive 8. We could also think of positive 9 and negative 8. There's some other ones out there, but I think those will take care of them. 1 and 72 are also factors. Negative 1 and 72. Also positive 1 and negative 72. Okay. Now, the goal is that we want these factors to add to the negative 1. Okay. Negative 9 plus 8 is negative 1. So that's the one we want. Just to show you guys, positive 9 plus negative 8 is negative 1, so we don't want that one. Negative 1 plus 72, that's equal to 71. We don't want that one. And 1 plus negative 72, negative 71, don't want that one either. Winner, winner, chicken dinner, right here. Now, what do we do with those numbers? Okay, we're just going to write one factor as the r, and minus 9, and the other one is r plus 8, okay, and that is our factored answer. You could also have it as r plus 8 and r minus 9. I will not take off points, or it does not matter what order you have them in, but that works. So you're going to need to know your multiplication tables for those there. I might show you a shortcut here in a little bit to help you know the factors of your numbers here. Okay? 4n squared minus 20n minus 200. What? First step for here is if you see big numbers, okay, bigger numbers, let's remove that greatest common factor. So they each share 4. Okay? So if we remove a common factor of 4, that leaves us with n squared 20 divided by 4 is negative 5. 200 divided by 4 is 50. 50. If you're not sure, type it in your calculator. When in doubt, type it out. 200 divided by 4. There we go. Okay, so we got that 4 out front. Next, we're going to use the trees. That's a pretty bad tree. Factor trees. So we're going to leave the 4 out front. Factor of this is n and n. Factors of 50, that add to negative 5. So 50. If you're not sure of all the factors of 50, what you can do in your graphing calculator is go under y equals, type in 50, and divide by x. If you then go to the table in your calculator, all the whole number or integer values are going to be your factors. So I see 1 and 50, so negative 1 and 50. Also positive 1, negative 50. What else do we see? 2 and 25, and 5 and 10. And 5 and 10. And some of you might be like, I already know what the answer is, but let's just again revisit our steps. Negative 1 plus 50 is 49, so that's not it. Negative 1 minus 50 is negative 49, that's not it. Negative 2 plus 25 is 23, no go. Negative 23, nope. Negative 5 plus 10 is positive 5, close, but not quite. Negative 5 plus negative 10 is negative 5, and that is the combination we want because that is negative 5. So our winner is 4n plus 5 and n minus 10. Don't forget about that 4 we brought out at the very beginning, okay? And then the others are from the trees, 5 and 10. Boom. Okay, so that's the final answer there. These are going to take a little bit of practice and definitely knowledge of your multiplication factors. Okay, so another one here, removing the greatest common factor. So they each share a 4. Let's get that out of the way. It won't always be 4. I know the last one was 4. P squared minus 4p, 48 divided by 4. Don't be a hero if you don't know. Just type it on in. Minus 12. Okay. P and P. And negative 12, you could think of it as negative 4, positive 3. You could think of it as positive 4, negative 3. You could also think of it as 6 and 2. And there's also 12 and 1, but let's just think about again, our goal is to get to negative 4. Okay, negative 4 plus 3, negative 1, no go. No go because it's positive 1. 6 minus 2, no go, that's positive 4. But again, our winner at the end here, negative 6 plus 2, means that we have 4, we have p minus 6, we have p plus 2. When in doubt, you can always factor or foil it again in order to find the answer. If you were to do that, worrying about the 4 later, p times p is p squared, plus 2p minus 6p minus 12. That's our FOIL method. P squared minus 4p minus 12, and then you could distribute the 4 afterwards and you get what we started with. Okay, so that's all for that one there. If perchance they share 2 things, so they share not only a 4 but an x, let's remove both of those. So 4x leaves us with x squared. 68 divided by 4, again, that's 17. And this time we have a positive at the end. 280 divided by 4, 70, I believe. Factors of 70 that add to negative 17. Now notice, sorry, this is positive and that's negative, okay? The only way to make that happen is both of these factors are going to have to be negative, because a negative times a negative is a positive, okay? Now, I don't know the factors of 70 that add to 17, so let's type in 70 divided by x, go to the table, think about which of these might add to 17. Okay, hey, 10 and 7. That was actually pretty easy. Negative 10 and negative 7. Okay, those equal negative 17. So we have 4x. We have x minus 10. We have x minus 7. Boom. That is a winning combination. Okay. So if this last one's positive and the middle term's negative, we're always going to have opposite signs in between there. Last example. Let's see if you guys can handle this one. It's an easy one. Okay. X squared. 40 that add to negative 13. You can use the trick. You could think of 2 times 20. That won't help you. Let's see, what else? Negative 10, negative 4. That won't do it. Let's type in our calculator. Five and 8. That will be it. Negative 5, negative 8, negative 13. Okay, so x minus 5, x minus 8. That's it there. Okay, so be careful, especially with the plus and minus. I encourage you to check your work with these. Let's see if there's any curveballs in some of these here. So all factor trees, all factor trees. Greatest common factors. So greatest common factor. Remove those first. And that will definitely help you move along with these. Okay. Please be sure that you're checking your answers to these problems. It'll be very helpful. And let me know if you need extra practice, because you will need to practice these skills, of course. Okay. Checkpoints coming up. So practice these. Take care of that. And thanks, guys.